One probability density function. What it shows. The PDF indicates the density of probability at each value of a continuous variable. It helps you understand how likely different values are. Use the PDF to gauge the distribution of probabilities and see how likely it is for a variable to be near a specific value. Key feature. The height of the PDF curve at any point reflects the relative likelihood of that value. The area under the PDF curve between two values represents the probability that the variable falls within that range. 2. Cumulative Distribution Function, CDF. What it shows. The CDF represents the probability that the variable will take on a value less than or equal to a specific point. It shows the cumulative probability up to that point. Use the CDF to determine the probability of the variable being less than or equal to a particular value and to understand how probability accumulates up to that value. Key feature. The CDF is always non-decreasing and ranges from 0 to 1. It starts at 0 and increases towards 1 as the value increases. Comparison of PDF and CDF. PDF, what it shows. Probability density at specific values. Use to understand the likelihood of specific values and the distribution across a range. Graph. The area under the curve between 2 points gives the probability of the variable falling within that range. CDF. Cumulative probability up to specific values. Use to determine the probability of a value being less than or equal to a certain point. Graph shows the total cumulative probability up to each value, ranging from 0 to 1. Where to use each? Use PDF to find out how likely a specific value is. To understand the distribution of values and the probability of falling within a certain range. Use CDF to determine the probability of a value being less than or equal to a particular point. To observe how probabilities accumulate up to a specific value. Understanding both the PDF and CDF provides a comprehensive view of the probability distribution for continuous variables.